This video we're going to look at how we do polynomial division. Before we do that, we're just going to look at numerical division, and we're going to look at just dividing how we do our long division. Because if we understand long division numerically, this will of course take us very close to be able to doing polynomial division. So first thing, in this example we have got 647 divided by 23, and we're going to divide this by going down our page. So this is different than the method that a lot of people would have used in primary school. But really what I'm going to do is I'm going to look at this 23 and I'm going to think what do I need to multiply 23, or how many times, sorry, does 23 fit into 64? So it fits in 2 whole times. So it fits in 2 whole times, and then what we can do is just do 2 times the 23, and that is going to be 46. And then what you do is you subtract. Now, good practice not to put a subtract sign here. So you know you're subtracting, but don't put a subtract sign here, especially when we get on to our polynomial division. So when we subtract, what you're going to get is 18. And I probably haven't left myself enough space here. And then what you must do is bring down this next 7. So this next digit, whatever it is, or in polynomial terms, the next term, whatever it is, it will come down. So that 7 comes down, and then what you're doing is you're seeing how many times this 23 goes into 187. So 23, we'll do a wee bit of working out for that. Just 23 times 8 would give you 184. So you can see 23 goes into 187 8 whole times. So you put an 8 up here on the top, and then you'll write your 184, and you subtract, giving you 3, and you can see there's nothing else to come down, so that's us finished. You could put a decimal point in and continue and get an answer to decimal points. That's not what we're interested in today at all. Okay, so what we have shown, first of all, this 28, the name for this thing is the quotient. So basically that's the whole number of times it goes in. 3 is the remainder. 3 is the remainder. And also, we could say that 647 divided by 23, it goes in 28 whole times with a remainder of 3, so that's 3 over 23, and obviously you would push that together and just write that as 28 and 3 over 23. But don't do that, just because we want to keep this so that we can understand it in this form, so what that means when it transfers to polynomials. Okay, our next example, we're actually going to go on to our polynomial division. So this is us dividing x squared plus x minus 4 by x minus 3. Okay, and we are good to go, so we're going to get cracking with this. So just set out your division sum like this. So x minus 3 is dividing your x squared plus your x minus your 4. Now, if we just put the brakes on a wee second and just look at this, I'm absolutely fine to write this down as it is, because I've got my terms in order. Now, what I mean in order, I've got here, first of all, I've got my linear term, and then the next thing after your linear term is numerical term, so that's fine. There's nothing missing. Here, I've got my quadratic term, I've got my linear term, and I've got my numerical term. Say my linear term had been missing, I would need to leave the appropriate gap. So it goes quadratic, cubic, quadratic, linear, numerical. So if one of those things is missing, you need to leave the gap where it would have been. Okay, otherwise the whole thing will fall apart. So the gaps must be left, they must be left in place. Okay, what we want to do, I'm going to be zooming back up to the previous example as well. What we did here, first of all, up here, we were seeing how many times the 23 fitted into the first thing, which was 64. How many times 23 fitted into this? So we've got, we want to see how many times basically x minus 3 fits into this, which sounds pretty horrific to figure this out. So what we do to make life easier is we ignore this minus 3, and we just think, really, what do I need to multiply x by to give me x squared. So if you think, what do I need to multiply x by to give me x squared? I will get x. So x is a linear term. So I line my linear terms up, so it goes up in my answer line above my linear terms. And then what you have to do, so what we did here, when we said up here, we said 23 goes into 64 twice. We then did 2 times 23, and you put that in below. So now what we're going to do is x times this whole thing. So this is where the minus 3 now comes into play. So it's x times this whole thing, x minus 3, and we're going to put that in here. Okay, so x minus 3 times x is going to give you x squared minus 3x, and then we're going to put a wee line. Okay, just like up above, we have got once we got our 46, and then what we did is then we subtracted. We did 64 minus 46, and we give us 18. So we're going to do exactly the same thing here. So, and I do this from left to right as opposed from right to left as you normally do when you're subtracting. X squared minus x squared, the x squareds cancel out, brilliant. And you've got x minus 3x. Think about that. X minus 3x is the same as x plus 3x, which is just going to be equal to 4x. So a lot of people will make mistakes in that. That's really where the mistakes will be made. So just take a wee bit of care on that, please. Okay. The next thing we did up above for a numerical example is we brought the next term down, whatever it is, 7. Okay, and it's the most immediate term. If that's a gap, then you bring down a gap effectively. You don't bring anything. But in this case, we have something. We have a minus 4. So we're going to bring down a minus 4. So we line just to show that that minus 4 is coming down. We arrow, I should say. And that's what we have. Okay. Next thing we have to do, we're forgetting about this whole top bit, the thing we're actually dividing. And we're thinking, what do I need to multiply my x by to give me 4x? So x times what gives you 4x? And of course the answer is positive 4. So plus 4, and it lines up above the numerical terms. And then your whole x minus 3 gets multiplied by 4 to give you 4x minus 12. And again, you know, you don't write down a minus because that will confuse things, but you know you're subtracting. So again, I do from left to right this time. 4x minus 4x is 0. And then again, be careful. Minus 4 minus 12 is minus 4 plus 12. So minus 4 plus 12 is going to be just 8. Okay. And then that is as far as we can go because x would not go into 8. So that's as far as we can go. All right. First of all, we're going to write down what we've got. Our quotient in this example is equal to the thing in the answer line. So it is just x plus 4. Our remainder is equal to 8. And also, we could say that x squared plus x minus 4 all divided by x minus 3 is equal to, it goes in x plus 4 whole times, and then plus you had a remainder of 8, so it's 8 over whatever you were dividing by, 8 over x minus 3. And you may be wondering why we're doing this. Well, I can tell you one reason, a bit of mathematics that you're not familiar with just yet, but you couldn't integrate this function, but soon enough you will be able to integrate x, you'll be able to integrate 4, and you'll be able to integrate x over x minus 3. So it does have a very, very important use. Our next example says divide 2x cubed minus x squared plus 3x plus 7 by 2x minus 3. So we're just going to write this out. We've got our dividing thing is 2x minus 3, and we're dividing a cubic this time. So 2x cubed minus x squared plus 3x plus 7. And just check, you've got your cubic term, your quadratic term, your linear term, and your numerical term. So I haven't missed anything, so happy days, I'm good to go. Now what you're doing is you're thinking, how many times does 2x go into 2x cubed? Or an easier way to think about it is, what do I need to multiply 2x by to get me up to 2x cubed? So my answer is x squared. So you put x squared into your answer line above the x squared term. What you then do is you multiply your 2x minus 3 by the x squared to give me 2x cubed minus 3x squared. And then all you want to do is subtract. Sorry, that's a mess. All we want to do then is subtract. So horizontal line and subtract. 2x cubed minus 2x cubed disappears. Minus x squared minus 3x squared is going to be plus 2x squared. And then what you want to do is bring down your next term. So if you bring down your next term, which is a plus 3x, and then what we want to do is see what do you need to multiply your 2x by to give you 2x squared. So 2x needs to be multiplied by x to give you 2x squared. So then we put a plus x up here in our answer line. And then you multiply your 2x minus 3 by the x to give you 2x squared minus 3x. Do a horizontal line again and subtract. So if you subtract, 2x squared minus 2x squared is 0. And then careful here again, 3x minus 3x is 6x. And then you're almost there. Bring down your next term, which is a plus 7. And then we have to think, what do we need to multiply our 2x by to give you the 6x? And the answer is plus 3. You then multiply your 2x minus 3 by the plus 3 to give you 6x minus 9. And again, subtract. 6x minus 6x is 0. Plus 7 minus 9 is plus 7 plus 9, which is 16. Okay, and that is it, done. So again, you can see we have divided it. If you're asked, your quotient would be this bit, your remainder would be this bit. And we could say, I'll just write this out, 2x cubed minus x squared plus 3x plus 7, all divided by 2x minus 3. It goes in, x squared plus x plus 3 whole times, squeezing us in here, plus 16 left over, and that's 16 over whatever you were dividing by, which was 2x minus 3. Our next example says, prove that the remainder when x cubed minus 2x plus 7 is divided by x minus 2 is 11. Okay, they have a wee trick in this one. We're dividing, our x minus 2 is our dividing function, and we're dividing x cubed minus 2x, so leave a gap where your quadratic term would have been plus 7. If you don't leave a gap, it will mess things up, so leave a gap where your quadratic term would have been. Okay, so what we're doing is we're seeing how many times this x goes into x cubed, or another way of saying it is, what do you need to multiply x by to give you x cubed? And the answer would be x squared. So x squared goes here, as this is where your quadratic term would have been, so it's lined up with where your quadratic term would have been. You then multiply your x minus 2 by x squared, which gives you x cubed minus 2x squared. Do a horizontal line, and then you subtract. X cubed minus x cubed disappears, cancels out, and then 0 minus 2x squared is positive 2x squared. Your next step is to bring down the minus 2x, and what you then want to do is see what I need to multiply my x by here to give me the 2x squared. So what does x have to multiply by to give you 2x squared? And the answer would be positive 2x. You then multiply your whole thing, your x minus 2 by positive 2x to give you 2x squared minus 4x. Do your horizontal line and subtract, giving you 0. Then minus 2x minus 4x is minus 2x plus 4x, which is going to be 2x. Bring down your 7. And your last bit of dividing is you're seeing how many times x goes into 2x, and it clearly goes in twice. So it's going to be 2x minus 4, and then you subtract 2x minus 2x is 0, 7 minus 4 is 11, and that is it. So just say, so remainder is 11. Could you just make sure you've got in your notes, if I highlight this in some way, shape, or form, just say leave gap where quadratic term would be. Okay, it's not there in this example, but that's where it would have been had it been there. Our last example says we are to simplify x cubed minus x squared plus x minus 6 all divided by x minus 2. Now, if this, another use for polynomial division would be if there was a cubic expression, or maybe even more, a quartic expression, so that's x to the power 4, and it was divisible by the thing which is on the bottom line. If it's divisible, then this would be a good way for us to go on and factorize. Okay, so if you, for example, this one does not factorize, it does factorize nicely, but it doesn't factorize completely, but this thing maybe would reduce if you divide a cubic by a linear, it takes you down to a quadratic, and then if you can factorize that, then you could factorize that using your sum and product method or one of those other methods you would have seen probably in GCSE maths. But we will see if this one works, and if it factorizes, then we will go on and do that. Okay, so here we are dividing by x minus 2, and we're dividing our x cubed minus x squared plus x minus 6. So we'll go through this one a wee bit quicker than we have in the previous ones. You need to multiply your x by x squared to get you up to x cubed. So you put an x squared in here. You then multiply x squared times your whole dividing thing, which is going to give you x cubed minus 2x squared. Do your horizontal line. You then subtract x cubed minus x cubed is 0. Minus x squared, that's a minus x squared, minus 2x squared is minus x squared plus 2x squared, which is just going to give you positive x squared. You then bring down your next term, which is a plus x. X then goes into x squared, x times. Then multiply your x minus 2 by x to give you x squared minus 2x. Again, you subtract, which would give you 3x. Bring down your minus 6 to give you minus 6. X then goes into the 3x plus 3 times, and then plus 3 times the x minus 2 gives you 3x minus 6. And we have 0. So that means that this thing does divide in. It divides in a whole number of times as there's no remainder. So what we have shown so far, therefore, we have shown that your x cubed minus x squared plus x minus 6 all divided by x minus 2 it simplifies down to x squared plus x plus 3. Okay. Unfortunately, this thing would not factorize down anymore, so this wouldn't work to factorize this, but this could have been used. I wouldn't be adding this into your notes, but you could say also that x cubed minus x squared plus x minus 6 is equal to x minus 2 upon x squared plus x plus 3. Now, unfortunately, you wouldn't be able to factorize that any further. This thing here, x squared plus x plus 3, is a non-reducible quadratic. You couldn't factorize that anymore. I couldn't simplify it anymore. So this is as factorized as this thing could ever get. But that's it, right? That's not what the question asked us. The question just asked us to simplify, and we have done that. We have shown that x cubed minus x squared plus x minus 6 all divided by x minus 2 just simplifies down to x squared plus x plus 3. And that is us done for this video.